Hi, everyone. Thanks for joining us for another on .NET Live. My name is Cecil Phillip, and today we're going to be exploring a really interesting actor framework in .NET called Proto.Actor. And why not bring the creator of the framework on to talk about it, right? I think that's a good idea. So Roger is here. He's going to talk to us about Proto.Actor. We're going to talk about actor frameworks and distributed computing, and maybe even get some samples and some demonstrations about how some of this stuff works. So why don't we start off with Roger? Why don't you introduce yourself to folks? Let us know about maybe who you are and what exactly do you do.
Yeah, thank you. So first of all, super great to be here. And so I'm Roger. I have a very long background in .NET open source. Started out somewhere in 2005, I believe, building ORA mappers and AOP frameworks. We had an ORA mapper called NPersist and an aspect-oriented framework called N-aspect. And then from there, I moved on and later created the framework Aka.net together with a few other people. And while building Aka.net, we saw that there was a lot of things that we had to sort of reinvent or build from scratch. So I thought, can't there be any better way of building that? And the lessons learned from that journey is really what triggered the building Proto.Actor.
Awesome. So I'm really interested in us diving into that story and learning not only what are some of your motivations behind building the new framework, but also just even seeing how it works. But before we do that, this is the point of the show where I always like to give a really quick shout out to the folks in our community. Every week we do on.net Live every Thursday, and we always have tons of folks from all over the world that join us from different countries, from different places, from different cities. And so I definitely want to give everyone a shout out. I'm looking in the chat right now. I can see we have some folks here that are from Romania. As I scroll on, I see we have some folks from, there we go. We got Sean here is from Tulsa, Oklahoma. I see we got some folks from Africa, Nigeria. I see some folks from India. Again, like tons of folks from all over the place. Here's someone from Somalia. Here we go. We got Brazil. We got folks from all over the place. So again, as always, definitely appreciate you folks joining us. There we go. We got Sweden too. I'm in Florida, so I'm in the United States on the East Coast of the U.S. And Roger, I think, are you in Sweden? Am I mistaken?
Yeah,
Is that where you are?
no,
Right?
that's correct. So Stockholm, Sweden here.
Awesome. That's great. All right. Now, with that being done, why don't we first jump off and let's take a look at some links. And I want to show or share with you some of the real cool things that have been going on in the community. So first off, I want to start off with, and let me get my screen on the screen. So a friend of ours, so Sean is actually in the chat with us right now on Twitch. So Sean and some of his friends are writing a book called Pro Microservices in .NET 6. This is going to be out soon. So if you're interested in learning what it feels like to build microservices using ASP.NET Core 6, using mass transit, Kubernetes, tons of other great projects and open source tools, definitely make sure you check out this book. This is being published by Apress. It's not out yet. It's available for pre-ordering. So if you want to go ahead and check that out, go ahead and do that. Looks like it'll be out on December 21st. So if you're interested in going ahead and getting like the ebook copy, and then looks like there'll be a soft copy as well. Next thing I want to talk about, DapperCon was this week. We've been talking about DapperCon for a little while. It happened this week, Tuesday and Wednesday. So was it Tuesday and Wednesday? Today's Thursday. Yeah, it happened this week, Tuesday and Wednesday. And so now all of the videos are available online for you to go ahead and check out. So if you missed the keynote, if you missed one of the sessions, they're all up and available on YouTube if you want to try them out. I personally did a session. I'd love for y'all to check it out. It's called, Zero to Hero with Dapper, where I have some demos in .NET and Python showing off things like service discovery and state storage and tons of other cool things. So if you want to, again, you can head over to the Dapper YouTube channel and you can take a look at some of those videos. I know for me, one of the things that I learned from DapperCon was there's a company called the Man Group. I believe that there's a financial institution over in the UK, but they have they're big supporters and users of Dapper. And they actually created this thing called Dapper Sidekit for .NET, which is a really interesting project that actually manages the Dapper sidecar process for you. without going into much into Dapper, Dapper runs in a sidecar model. So instead of you having to run your .NET app and then run Dapper, this library or this tool kind of just run them both for you, which makes it a little bit easier for you to get started and stuff. So if you're interested in that, you want to go ahead and check it out. You can head over to the man group repo at dapper-sidekick.net. They have tons of other open source projects in there as well, so you could always go and take a look at those. And last but not least, .NET Conf is happening very soon, in less than just about 18 days. .NET Conf, November 9th through 11th. We're going to have tons of talks from the open source community. We're going to have tons of talks from our MVPs and obviously Microsoft FTEs as well. And actually, I believe the agenda is now up. So if you want to click through here and see what's happening and what are some of the things folks are going to be talking about on those different days, you can go ahead and check out the schedule for those various days as well. There's digital swag, there's local events. You can click on the speaker directory and see some of those folks that are speaking as well. So again, .NET Conf this year is going to be really exciting. We're going to be releasing .NET 6 and tons of other great things. So definitely check it out. It's free, it's online, and hopefully you learn and pick up some new tips and tricks as you're writing your applications. Now, that's enough for me. Again, this is the part of the show where I say this is no longer the Cecil show. This is now Roger's show. So I'm going to take my screen off. And Roger, why don't we kind of dive into your topic, right? Like let's talk about Proto.Actor.
Yeah.
Now, you mentioned a little bit, like you used to work on the Akka.net project.
Yeah.
And now you're working on Proto.Actor.
Yes.
And then I know some folks that may be watching, they may be familiar with other things like Microsoft Orleans, which is another actor framework that's there as well. So could you very briefly tell me, why did you think that there was a need for there to be another actor framework, or what are some of the differences between the work that you're doing versus some of these other ones?
Yeah, definitely. So when we started building Akka.net, that builds on a sort of translated model from the Erlang way of building actors. It's very fine-grained, it's very nitty-gritty. You have complete control over everything. And at the same time that we built Akka.net, you guys at Microsoft released Microsoft Orleans, which introduces new programming model, which was the virtual actor model, which is similar but not identical to how it works in the Erlang and in the Akka world. So there was a lot of discussions on which model is the best model and when should you use which. And for me, I found it a little bit frustrating that you had to choose. You could either go down the Akka or Erlang style of programming and sort of having the extreme control over everything, or you could go the Orleans way and not having as much control, and that's more of a distributed programming toolkit, but you don't really have the primitives to build fine-grained concurrency control and those kind of things. So somewhere around there, this idea was born that maybe you could sort of leverage the best of both worlds. Why can't you have both? Like this meme on the internet, I want to have both. Right. So I started thinking, can't I use the fine-grained model and then build the virtual actor model on top of that? Because one drawback of the Erlang or the Akka model is that it's a little bit alien to developers, and there's a big learning curve and getting into it. And the virtual actor model that was introduced in Microsoft Orleans is very much more straightforward. If you have some form of background in object orientation and you have used, say, gRPC services or something like that, then you can understand that model quite quickly. So it's a very nice and low learning curve model to use. So I wanted to combine that, and there was no library at the time that did both. And I still think that there's no other framework that does this, that has both the fine-grained, very low-level, high-performance control, and then the bigger abstractions on top.
Got it. One of the things that, and I was reading the documentation for your project, which, I always appreciate when open source projects actually have documentation that explains like their purpose. I was reading through your documentation, and I realized, initially I thought Proto.Actor was only for .NET. Like I thought it was a .NET project. Like those were my impressions, right? But as I went through your docs and your samples and things of that nature, I realized like there are other programming languages as well that work with the framework. Now, are those other projects, or the language support for those other languages only for like, I guess I'm trying to ask, like, do they interoperate? Like, can I speak to, looks like you support like Go and you support Kotlin and you support .NET. Like, can they all talk to each other using those similar actor constructs?
Yeah, exactly. And that was one of the main ideas, because when we built Aka.net, which is very much a verbatim clone of Scala Aka, it's basically line for line porting of Scala Aka, but still Aka.net and Scala Aka cannot interrupt on the network level, because the object graphs in the JVM and the object graphs in .NET are not the same, and you don't have the same serialization, etc. So it was just impossible to make those two work together in any same way. So I thought that what would happen if I were say, CTO or decision maker at some company, and then we invest in this kind of framework. Let's say we go all in Microsoft Release, for example. And then a few years later, someone says, we need to start building for Go, for example. Then there's no easy way to gradually migrate from .NET to Go, because then you need to find something else on the Go side which works similarly to what you have on the .NET side. So I thought that, what if we can make all this interop and work together? Then it doesn't really matter if you go all in for .NET, if it's easy to make it work on another platform also. So I wanted to have something that was interoperable, and of course fairly small to build also, because if you have multiple frameworks of the same thing really, but for different platforms, then that's going to be a maintenance nightmare. So I wanted to have something that was fairly small, isolated, and easy to port over. So that's how the idea came to be.
I'm interested to hear about, and I know folks want to see demos. We're going to get to the demos, I promise. Yeah. But I'm really interested to hear about how did what was the work that was involved to make that happen? Because I'm guessing you were going to have to write some type of specialized serializer or some type of protocol over the wire that would allow all these different languages to interoperate. Because I'm guessing you're not just like passing JSON or something back and forth. Yeah. I'm guessing it's a little bit more low level of a message protocol that you're actually using.
Yeah. So as I said before, I wanted to have something that was fairly small and easy to port, and that had me thinking that why should we have to write all of this infrastructure from scratch? For example, in Aka.net, I wrote the serializer called the Wire or Hyperion, and Aaron was writing the network protocol called Helios, and then we had a few other people writing the cluster consensus algorithms, and there's just a lot of work to make all of that work. So I was thinking that serialization is basically a solved problem. There are standard formats for serialization, be it JSON or protobuf or Avro or anything like that. So I thought that protobuf is fairly fast, it's fairly compact, and it works on most platforms. I didn't need to have anything that was the fastest or best, just mainstream enough to work on most platforms.
Got it.
And the same thing for networking. Instead of building my own network protocol and network layer, I thought that gRPC was completely new out of the box back then. So I thought that this looks interesting, and it has full duplex streams, so I can stream data back and forth. So I thought that, yeah, this sounds nice, and it's supported by Google, and they build their microservices on top of this protocol. So that was the birth of Proto.Actor, that taking existing things and composing software rather than building software, taking things that already exist and make them work together. So for example, for cluster, instead of writing our own Paxos or Raft protocol and all of that to make all the members of a cluster to know about each other, that's really a solved problem also, because you have service discovery tools like Console or Zookeeper, or you have metadata in Kubernetes, which can provide you information about what members or hosts or pods are around. So I thought that, yeah, let's just piggyback on as much as existing technology as possible. So,
and I think that's a good idea too, because whenever you go into a business or an already established ecosystem, more than likely they're going to already have some things that they're already using, right?
Yeah.
And so now if you're supposed to go ahead and say, well, I wrote my own service discovery mechanism, right? And I have my own thing, and it only works with Proto.Actor between my nodes or sliles or clusters. Now you're like, okay, well, but we have this other stuff. Like, how does it plug into this other stuff when we have investments in other places? So being able to like leverage, like you said, like that infrastructure that's already solved the problem, I think is really great.
Yeah, and you also get the benefit that those technologies are often very much battle tested and built by large companies that have the power to actually make those as powerful and good as possible. So
okay,
it's a little bit naive to try to compete with the consensus and the network protocols in Kubernetes, for example, and try to build that yourself. If you can leverage something existing, then that's a win in my book.
Yeah, I think that definitely makes sense. Roger, why don't we do this, right? Because I feel like we've been talking about this a lot. Why don't we take a look at some code? Right? I think it's code time, right? I'm sure we're gonna have a lot more questions from folks in the audience and even myself as we go on. But I'm really interested to see even what like that getting started experience with Proto.Actor kind of looks like, and then obviously like building up into like some more complicated demos, if that makes sense.
So I have this small demo here on how to build a distributed system with very, very little code, and to try to not make things look too alien or too different. I'm using standard technologies in .NET with a little bit of Proto.Actor glue on top. So in this case, we have a client and a server. And right now we're looking at the server code. We can see that I spin up an actor system, and I say that I want this to talk to the network on localhost on port 8000. And I say that I want this to start up this networking module now. Then I create this standard .NET channel. This is a standard normal .NET code. And then I say, I want to create a channel publisher. And this channel publisher should be created using a context from my Proto.Actor framework. I want this to start an actor behind the scenes called publisher. And I want this to consume data from this channel. So we have the channel that we created here. And I say that whenever you send data to this channel, I want that data to go into this behind the scenes actor, which we call publisher. Then I have a little loop, which just loops from 0 to 30 and sending messages to this channel. So there's very little Proto.Actor related code here. We have this line and then that we start the remoting module. That's the only actor related bits. Otherwise, we have standard .NET channels and we write to those channels. Then we have a client which does very similar stuff. We start up the actor system and we bind to localhost. We start the network. Then I say I want to have a PID, and PID in Proto.Actor is a process ID. So this comes from the Erlang world, where they have the same concept of a PID, which basically points to an actor somewhere. So we say I want to point to an actor on localhost on port 8000, and the actor's name should be publisher, which is the name that we used in the server. Then I say I want to have a channel, and I want to have a channel subscriber, meaning that whenever this actor that we're pointing to, whenever that produces data, that data should be sent to our channel. So it does the reverse of the server. The server has a channel going into an actor, and the client has the actor sending data to the channel. And then we do the same thing. We have a for loop, and we just read all the data that comes in from this channel.
Got it. And then just to be clear really quickly, if you could like go back to that sample.
Yeah.
So just to be clear, when you showed the channel publisher and channel subscriber, like those are coming from Proto.Actor, right? Because I know that's not a .NET thing, like not out of the box anyway. Like that's from your framework. And so now these are kind of facilitating the merger or like the interoperability of channels, .NET channels and Proto.Actor.
Yeah. And one of the reasons for this is to sort of lower the barrier for entry for using these kind of technologies, because many developers are familiar with channels and concurrency concepts in .NET.
Right.
And while they find that actors might be a little bit hard to understand, but if you see that you can use them together, then it's easier to get up and running and start leveraging the power of it. So
so that makes sense.
In this case, we have the server on the right hand of the screen, and we have a client on the left hand side. And just to show, we can run two clients, for example. So we start the server, and we start a client, and we start another client here. So, and now we have to wait for .NET to compile and start running.
Okay. And then while we do that, we actually have some questions. So why don't we take a look at the chat really quick and see what folks are talking about. So this one is coming in from YouTube. And the first question is, in theory, can the actor model be used just fine with domain models from DDD, so domain-driven design?
Yeah, so that's a great question. And actors works very well with concepts like CQRS, where you have domain aggregates that, for example, use event or command sourcing to take incoming events, store that to some event sourcing model, and then when the system restarts, it can replay all of that. So you can model your actors as aggregates, but a better way would be to model your aggregates separately, but then you use the actor as a sort of proxy or a host around the aggregate.
Right.
Because then you can, of course, easier unit test your aggregate routes and see that things works as you want.
Got it. That makes sense.
Yeah. So what we see here in the demo is that when the server is completed, we can see that the both clients also stops running, because channels in .NET have this completion mechanism that you can say that this channel is now completed, so there's no more data to read from it. So what we have done here is that we also propagate that over the network. So when the channel that produces data to the server actor, when that channel is completed, we propagate that and tell the clients also that there is no more data coming in for you. So this for loop that is looping over all of the data in the channel, that for loop will complete and exit them. So it's just like coding normal .NET code, and we just add the network support for you, so to say.
Nice. So right now, So just to be clear, so right now the client and the server are definitely running on different ports, right? Because I saw you had like a binder or something of
Yeah,
that sort
yeah.
that like made it like attach it to that port.
Mhm.
One thing I also noticed as well, like you had the concept of a PID, a PID, like so I guess that's a
Mhm.
process ID.
Yeah.
Whenever you create actors, are those actors actually running in separate processes, or are they running in process? Like how is that working?
Yeah, so I've seen a lot of confusion around the word process when it comes to actors, because when you read about technologies like Erlang, they say that you can spawn millions of processes very quickly. But what they mean when they say a process is not an operating system process. It's not like starting a notepad.
Yeah.
It's more of this fine-grained actor concurrency primitive. So when we say PID in Proto.Actor, it actually points to an actor behind the scenes. So it runs in process,
Mhm.
uh, but it also offers this concept called location transparency, because
Right.
we can point to this PID on another process. So you have the host and the port and the name of the actor. So you can see that basically like a phone number. It doesn't matter if you're standing in the room next to me or if you're on the other side of the world. If you have my cell phone number, you can still call me and talk to me. So it's very similar to that concept.
So it's almost like it's like I would consider like an actor reference to a particular to an extent, right?
Yeah,
Like
exactly.
this is an
And
abstract connection to this actor in
yeah,
outer space.
yeah, and in the actor world, it's actually called exactly that. It's called an
Oh,
actor.
okay.
So that's the name there.
Got it. I'd love for us to talk a little bit more about like some of the similarities and differences between like Akka and Orleans specifically. Like
Mhm.
for example, I know with both of them, I believe, like there's this concept of managing life cycle, like actor life cycle, right? And being able
Mhm.
to like tie into events and things of that nature.
Yes.
Is that something that we have to do as well with Proto.Actor, or is that abstracted, or like how does that play into how we design our application?
Yeah, both yes and no. So when you're using the normal actors that are sort of running in process, they do have the life cycle, and you can, if you want, hook into that. So you can have events where when they start, when they restart, or when they are stopped, etc. So
Sure.
so you have the capability if you want to hook into that. But when we're talking about cluster systems, when you have a form of, say, microservice system, or some form of distributed data processing, then we use this virtual actor model from Microsoft Orleans instead. And in that model, you can say that the actor always exists. So even if it's not really started, if someone wants to talk to this actor, the infrastructure will make sure that this actor is
Is
started
there.
up somewhere in the cluster.
Got it.
So we make it transparent for the end developer, that they don't have to care about this life cycle management. Uh,
Got it. All right. Let's take a look at some of these other questions that are coming in from YouTube.
mhm.
So Mohammed had a question about the demo that you showed.
Yeah.
And so he's like, what about messages that have been sent before clients were up and running?
Yes, so this is really just an implementation detail of this demo, that we have this publisher, the channel publisher actor. Uh, we could very well buffer and remember all the messages that has been sent. So
Mhm.
whenever a client comes in and say, hey, I want to subscribe to this data, then the server actor could say, yeah, I have all these messages I've already sent. Here, please take all of them. But you also probably need to have some form of cutoff, that if you store all the messages you have sent forever, then you're going to run out of memory eventually. So having some form of bounded buffer would still make sense in that case.
Got it. Okay. And then one more question we have from YouTube. Patrick is asking, is the transfer encrypted? So I know you mentioned we're using gRPC, but like by
Yeah.
default, is that TLS connection back and forth, or?
Yes, so we actually expose the entire gRPC connection to the end developer. So you can configure that exactly how you want with the standard gRPC. So you can configure it to use certificates, or you can set up things like compression, etc., on this gRPC stream itself. So that's one of the design goals. We didn't want to build the network layer. We wanted someone else that knows about security and performance and all of that to do that, and we just reuse that technology.
Got it. Okay, that makes sense. Now, I kind of wanted to. So that was Patrick's question. So Patrick, hopefully that answers the question for you. I kind of wanted to dive back into some of the other interesting features that we have, and maybe you have some demos for these as well. You spoke a little bit about the networking stack. So I'm guessing
Mhm.
there's not only just remoting, but I'm guessing there's support for creating clustering, right?
Mhm.
And when I think about clustering, I'm thinking I have multiple nodes, like multiple machines or
Yeah.
VMs or whatever the case is, that I could have instances of my actor system running. And
Yeah.
now I could say, hey, I have these types of actors on machine A and machine B,
Mhm.
or some collection, a subset of them. And then now in my client, I could just start sending messages out. Is that do we have support for that type of stuff?
Yeah. So that's where we use these existing technologies like console or zookeeper or kubernetes, because not having to build all that ourselves gives us the time and ability to focus on just building the features that we want to have instead of focusing on all these other bits. But Kubernetes is pretty much the de facto standard of running container systems nowadays. So having that as a default cluster mechanism is really, really great, because a lot of companies use that. And if we can just show that, yeah, we plug into your existing infrastructure, and the environment will tell you that there's now 10 pods running. These are the members of your cluster, and then those members can then talk between each other and say that, yeah, this actor exists over here. Uh,
Got it. That makes sense. So I know you had that repo that you were showing with
mhm.
a bunch of samples. Do you have any samples of showing us like how to at least how the code for that kind of looks like? Like, could you show us that really quick?
Yeah, sure. So let me share my screen.
Yeah, sure. Go ahead, pop up with the screen. And then for folks that are in the chat, feel free to go ahead and ask us any questions you have. If you've ever tried Proto.Actor before, let us know. If you're new to the actor framework, let us know too. If you're interested in like what some of the use cases are, like those are all definitely things that we could have a conversation about really quickly.
So instead of showing nitty-gritty code, I think we can take a little peek at the actual website.
Oh, that's a good idea.
So we have documentation and articles about how you build this kind of high availability systems using Protocluster. And this will explain in detail how the underlying technologies works and why we built the things the way we did, so to say. So, for example, here we explain the concept of location transparency, that when we have these gRPC streams,
Oh,
the actor X and Y here can talk to each other. They don't need to know about the underlying transport, so to say.
right.
And the same thing for clustering. As I said, we have console in Kubernetes and etcd and zookeeper, etc. And we describe the background for that this is a complex area of computing, and it's hard to get right. So we don't want to get into this situation where you're running in Kubernetes, and Kubernetes knows about all the pods and all the things that's going on. But then you have to sort of reinvent the wheel and have your own cluster within the cluster. It's simply just overdoing it. So we choose the easier approach to just be piggybacking on existing technologies. But regarding the examples here and coding, we do have very, very fine detailed information about how the cluster mechanism works. And when we're talking about these virtual actors, you no longer use this concept of a PID. The PID is still there behind the scenes, but then we have this other abstraction called a cluster identity, where we say that, yeah, we have an identity, which is the name of some entity, be it a name of a player or scoreboard or asset or IT device or anything like that. And then we also have the concept of a kind, which is sort of the type or class of this thing. So we can say a player of type or an actor of type player with the identity Roger, and then we can address that actor within the cluster.
Got it.
So since this is a backend technology, it's hard to make any super interesting demos to look at this, because in the end it's mostly about passing data between nodes. But we do have this Proto.Actor real-time map, which is a very complete example based on actual real systems, but slimmed down to just showcase the concept. So in this case, we have a system that runs in a cluster. It can run in Kubernetes, and you can have multiple nodes. So if anyone is interested to look at the code for this, the code exists on GitHub, and it's under our own repository. So it's /asynchron/realtimemap.net.
And I'll put up the link too. There you go.
Yeah,
you should have the link on the screen right now. So if folks want to go ahead and clone the repo or star it, or even submit issues and PRs, I'm sure Roger would appreciate it.
Yeah. So up here we have the name of the organization and the demo.
Cool. So now you're saying, so if they run this application, so now we'd see like a map kind of like that, right? And could you tell us a little bit about like what this map does, or how does it, what does it do?
Yeah, definitely. So let me start this up, and let's hope that the JavaScript world don't play any tricks on us when we are on a live demo.
Okay.
So it seems like.
So you just went ahead and just hit the run button, right? And so you're just waiting for it to get started.
Yeah.
Okay. And is it spinning? It looks like it's spinning.
Yeah, I'm not quite sure what's happening. If it's because we're doing screen sharing and streaming, that computer maybe.
Yeah, that's what always happens, right? Like anytime you're streaming, Visual Studio, your IDEs, like anything that's on your machine just spins. But while we're waiting for that, looks like we had another question or comment that pops in at YouTube. Let's take a look at this really quickly. It says, I'm curious about considering migrating an application towards an actor-based model. Wouldn't this increase complexity and hit the performance? A common mistake would be to make every class an actor. So I don't think every class has to be an actor, but I think we're more talking about like the work, right? Like you wanting to distribute the work around nodes. But Roger, why don't let you talk about that? I'll let you answer that.
Yeah, so that's a great question. And when I see developers going into starting using actors, many become sort of overexcited about that initially and try to make everything an actor, because it just seems like a good concept to have everything an actor. But in the end, like you say, it's just use it where it makes sense, so to say, because you don't need to have everything as an actor. You could still leverage all of your standard legacy standard code, but you could use actors, for example, for concurrency control. Let's say that you have some form of message queue pipeline where you consume messages from Kafka or RabbitMQ, and you don't want to have concurrency issues where multiple consumers write to the same database entry, for example, then you can use actors for concurrency. Or if you want to build some form of real-time microservice messaging thing, then you could use actors, cluster actors, for example, for doing that. So see it rather as a toolbox which you can use for different use cases, because you need to be aware of where it makes sense and what the pros and cons are, because many times you might think that, actors are similar to some form of message queue, but message queues are durable, while actors by default are not when you send messages. So
yeah, got it. And that makes sense. All right, are we? Is it still
think we
building,
are
running?
Yeah, maybe this was too brave to try to write something in JavaScript.
That's fine. Is it still trying to load up?
Yeah.
Looks like it's slowly
The
coming.
computer is very, very slowed down right now, so I'm not sure we're gonna see this.
Okay,
But
that's fine.
as prepared TV baker I am, we can.
Do you have a video? Is that what you're gonna do? Are you gonna play a video?
Yeah.
Nice.
So let's see. So.
Oh, nice.
I have pre-recorded. This is an earlier version of the same demo, but what we see here is actual IoT devices that get data from real devices and then fed into actors which model each of these devices. So each of the cars on the screen is an actor which has some position and a bearing and a speed, etc. So you can have business logic inside your actors that says that, now you're going in the wrong direction, for example, or now this car has been standing still for some time. And what we do in this demo is that we also take all the data that comes into these actors and then send them to a special actor which talks to Signal R. So in this case, we have the browser talking to the backend using Signal R, and then this Signal R actor, that PID, is passed to all of the IoT vehicle actors. So those vehicle actors can then send their position and update that in real time because they have this PID. So it's like they're talking on the mobile phone with this Signal R actor.
Nice.
And we also modeled this with what we call a viewport actor. So because the user will look at a specific part of the screen, so you have an upper and lower bound of the longitude and latitude of what you're looking at right now. So having that model as an actor on the server side, so the server knows that this specific user session is now looking at Oslo, for example. Then, of course, we don't need to send all the data, for example, all the cars in the US, for example. We only need to send data for the cars in Oslo. So that also gives us the possibility to model things like, we have the screen, or we have the assets themselves. So how do I stop sharing now?
Oh, I could just take your video off. That's fine. But one of the things that I know often comes up is, so you showed a lot of actors. There's probably hundreds or maybe thousands of actors in that demo. How heavy is an actor? Right? Like how many? Like if I have a laptop, let's say my laptop has 8, 16, 32 gigs of RAM. Right? Like how many actors can I comfortably run on my machine before it destroys it? You know what I mean?
It's a little bit of how long is a rope, but it depends on how much state do you hold in your actor, because if each actor has a lot of state, then of course each instance of those actors will consume a lot of memory. But that's one of the key things that we try to do in Proto.Actor, that we focused on performance and memory footprint, because we wanted to have something that could be used in extremely high load systems. So if we look at the number of bytes, I would say that an actor is probably around 20 bytes or something if you just look at the actor itself. But then there's other things that you have the PID, so just the fact that the actor has a name that will allocate some memory for the name alone. And then you have these mailboxes where the messages goes into the actor. So it's hard to say exactly a number, but you can easily have millions upon millions on a single node, unless you have a lot of state in the actors, because then the rules change completely.
Yeah, that makes sense. I asked too from the perspective of, I know sometimes folks compare actors to threads, right? Like I have a thread of execution, right? Something that's not running in my main my main stack, and I want to send it somewhere else, and when it's done I come back, right? Like I'm distributing the work. And I know I believe threads in .NET at one point in time, I don't know what it's like for 5 and 6, but at one point in time I believe threads in .NET were a megabyte. So threads are fairly expensive to allocate. So hence why I was asking, like, is the allocation of a lot of actors expensive? And it doesn't really look that way, because it looks like you had thousands and thousands of them.
So what we do is we actually multiplex these actors on top of the default thread pool in .NET, for example. So they run the same way as a .NET task do. So we are not allocating, say, a dedicated thread per actor, but rather whenever an actor receives a message, we check, is this actor already executing somewhere? If it's not executing somewhere, we just say to the thread pool that start executing this actor. And if there's new messages coming in at the same time while it's already processing, we can allow it to keep processing for some time. But we also have boundaries for that, so not a single actor will hog this thread forever. So there's cooperative multi-threading going on there.
Right. And I think, and to kind of add on to that point, like, so Sean is in on Twitch. He's asking this question. So an actor is not one-to-one with a thread.
No, exactly. It's more similar to a task in .NET. That's also one of the things that we designed in Proto.Actor, which was a design mistake we did in Arca.NET, because in Arca.NET we made the mailbox or the message consuming pipeline. We didn't make that asynchronous in terms of async await in .NET. So in order to support async await in Arca.NET, that was some really hardcore magic to make that work. But in Proto.Actor, we just use the default primitives for that. So whenever we schedule something, we just run it as a task on thread pool.
Got it. Another question coming in from YouTube. So can you also send streams? So I believe this was from the earlier demo where you were sending messages. So I'm guessing this person is asking, can I send a stream and stream bytes back and forth versus just sending single messages?
We don't have any support to send this form of network streams or socket byte streams, if that is the question. But we do have support for streams in terms of pub sub streaming data to multiple consumers, etc. So it depends a little bit on what they are actually asking about, if it's the low level socket raw binary streams, or if it's more high level pub sub streams.
Okay. Yeah, and so I'll give them a second to answer that question. Some more questions coming in. So considering that actors need to remember the states to the fire and forget style, can somehow the actor model be considered an anti-pattern, having in mind maintainability versus scalability?
Yeah, so as I said earlier, that actors work very well with event sourcing or concepts like CQRS. So we have built-in support for persistence in the way that whenever a message comes in to the actor and this message updates some form of state in the actor, then we can take that message, serialize it, and save it into a database. So what happens is that you still have to hit the database when stuff comes in, But since you're stateful, your actor holds state as long as it lives. You don't need to read the state back for every request. So if you take a completely stateless system, then you first need to read something up and apply some business logic and potentially write it back.
Right.
While in the actor world, you cut the IO operations basically in half, because you still need to write, but you don't need to read every time something happens.
Got it. And that makes sense. Another really interesting question, also coming in from YouTube. This person's asking, now with the spread of events or message-based cloud services, wouldn't it be easier to use these compared to the actor model implementation? I love actor model for on-premise cases, though.
And I would mostly agree. So for quite a while, I was thinking that, yeah, maybe the ship has sailed for the actor model, because serverless and cloud computing is sort of ruling the world nowadays. But there's still very much a sweet spot for use cases where you need this raw performance, where you need to be able to do the low-level nitty-gritty stuff and have this control on even if it's not on-prem, but let's say that you're running a Kubernetes cluster in GCP or whatever. If you have the control on how things are scheduled, how this state comes up into memory and all of that. So it will be easier to write faster systems if you have the right tools for it. Yeah.
Sure. But it is possible that actor frameworks, and particularly Proto.Actor, can interoperate with a lot of these messaging systems, right?
Yeah, definitely. So for example, you could easily have something like a serverless function that just makes a gRPC call to an actor in a cluster somewhere. So you can still leverage the serverless, for example, as an API gateway in front of an actor cluster.
Got it. That makes sense. All right. So we are coming close to time. We have just about 5 minutes or so left. If you have any more questions for Roger, go ahead and put them in there. But for Roger, for you, what I want to ask now is, a lot of folks, particularly a lot of .NET folks, like we hear a lot about actors, but we always don't know what they are, what are some of the best use cases. And then even after we understand the use cases, now we have to understand the framework, right? Like we have to learn the thing. What would you say would be a good place for folks that are new to actors in general to start learning about using Proto.Actor specifically? Like, do you have, I don't know, obviously you have docs. We saw your docs, but is there, do you have Discord channels and GitHub discussions and all these types of things?
Yeah, so we are a little bit scattered all over the place right now, but the main discussions are going on our Slack channel. And we have a link to that on the Proto.Actor site. Up to the right corner, there's a link to the Slack channel.
Got it. All right.
We also have this boot camp, which is in the documentation, but it contains lessons with the code examples that do these steps to build this system. So it's some interactive learning course also on the Proto.Actor site.
Got it. Okay. Now, I know Proto.Actor is open source, right? So it's on GitHub, it's an open source. What do you think would be a great contribution from the community? Like, do you need help with documentation? Do you need help with samples? Do you need help with folks trying out new products and features and things like that? Like, what are some of your core needs in this moment that would really be helpful from the community to help out with?
Yeah, so documentation is definitely the number one priority, because that's what helps new developers to onboard onto a framework. But as in many cases in the open source world, a lot of developers like to contribute code because that's very visible that I wrote this fast thing over here. Not as many are interested in writing documentation. So it usually ends up on the core maintainers to actually do that. And for the documentation, we actually have a bounty source program for Proto.Actor. So on the Proto.Actor website on GitHub, where we have the source code for the web pages, so to say. We also have a list of the articles that we are actually paying for the community to write.
Oh, nice. So that's a good incentive, right? Like if folks are interested in writing articles, there might be a little bit of incentive there for y'all to try that out. Cool. Oh, it looks like we did have one question that came in. I'll just read this one out. So you mentioned that Proto.Actor uses gRPC. So does that mean that Proto.Actor can only really run on web servers that support HTTP2 and not anything else?
Yeah. So the default implementation is gRPC. So that's definitely a requirement that you have support for
HTTP2.
that.
Yeah.
That being said, it's not impossible to implement something else, because it's still mostly about sending data from one point to another. So it's completely possible to implement something else. For example, we did a similar thing with the old gRPC versus a new gRPC library, because the original gRPC library in .NET is the native libraries from Google. And then we have gRPC.NET, which came out later. So we basically abstracted the channel creation and all of those bits. So we have the endpoint actors and all the communication abstracted away, and then the gRPC part just becomes the thing implementation detail.
Got it. That makes sense.
Yep.
That makes sense. All right. So it looks like we're at time. We don't have any more questions, but Roger, I think this was great. It was definitely insightful to hear some of the insights and some of the motivations behind you creating Proto.Actor. I really like that real-time map demo too. I think I'm going to download it on my own computer and try and play around with it myself. Do you have any, I don't know, parting words or any last calls to action that you want to tell the community before we call it a day?
Not really in that sense, but I do think that developers in the .NET community should not be as afraid of open source, because I see this, since we have Proto.Actor in Go and Kotlin, and the Proto.Actor Go community has been a lot better at picking things up, and they are more self-sustaining and sort of running the Go part of the framework by themselves. So that would be interesting to see the .NET community stepping up and not being as Microsoft centric as we have been in the past, maybe.
Sure, and I could definitely agree with that. We as a community could definitely do a little bit more, be a little bit more independent when it comes to .NET and using things and kind of just supporting each other, right? Because at the end of the day, that's really what it's about. So again, Roger, it's been great. Thank you so much for having us. Our audience that have been watching us live, that's been with us so far, thank you all for watching us also. I know I missed some countries really quickly. Like I'm going to shout them out really quickly. There we go. We see we have some folks from Hungary, from Italy that are in here. I know we mentioned Brazil and some of these other folks. Again, thank you all for watching. We'll be back again next week, Thursday, for On.NET Live. Hope you all join us. And until then, I hope you all take care, and I hope you enjoy the rest of your day. So, bye, everyone.
Bye-bye. Thank you for having me.